Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about intervals of concavity.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals a negative x to the third power over x squared minus 4, and we have to find the points of inflection, discontinuities, in open intervals where the function's concave up and concave down. Now, what we want to do here, I first want to find where it's discontinuous. And since this is a rational function, it happens when the denominator is really going to be equal to 0. So I take that x squared minus 4 set it equal to 0, put a little note here, it's kind of easy to do. X squared equals 4, x equals plus or minus, well, square root of 4 to both sides, right? Or square root of both sides plus or minus 2. So we have a discontinuities, we can write it out here, discontinuities at x equals negative 2 and positive 2. And we'll keep that in mind, okay? We'll keep that in mind there. So now we defined the points of inflection and its concavity doing the second derivative test. And we need to find the second derivative first. So to find the first derivative on the way there, f prime of x, we're going to use our quotient rule. All right, negative stays out front here. And we have derivative of the numerator, we have 3x squared times the denominator, x squared minus 4, minus derivative denominator, 2x, times the derivative the numerator itself, 3x squared. Oh, sorry, x squared, not 3x squared, that's a derivative. X to the third power. Almost messed this whole thing up. Okay, pay attention to my notes carefully here. Denominator squared, x squared minus 4 squared. All right, let's simplify where we can. F prime of x here. All right, negative stays up front here, but 3x, we just multiply this out, right? 3x squared times x squared is 3x to the fourth power. Let's make sure that's over right here. Okay, just so I don't forget that negative there. And then 3x squared minus times a negative 4 is a negative 12x squared. And then 2x times x to the third power is x to the fourth power, 2x to the fourth power, subtract that, 2x to the fourth power. And our denominator is still that x squared minus 4 all squared. Again, let's simplify this one more time. F prime of x is equal to the negative stays out front, but we have 3x to the fourth power minus 2x to the fourth power, and we just have x to the fourth power. And again, that minus stays there. And then we have a minus 12x squared here. All over that x squared minus 4 all squared. Okay. And here's where we're going to do the second derivative, and it gets kind of crazy here. Okay? So again, we're using the quotient rule. Let's do f double prime of x, and let's take our time here. Follow the same process, you'll get it. Negative will stay out front, but the quotient, we take the derivative numerator, which is a 4x to the third power minus a 12 times 2 is 24x, times the denominator, x squared minus 4 all squared, minus the derivative of the denominator, which is a power rule, chain rule thing going on here. So 2 times an x squared minus 4. Subtract the exponent by 1, we're good. Times the derivative inside, which is a 2x, right? Yeah. Times the numerator, which is just that x to the fourth minus 12x squared, all over the denominator squared. X squared minus 4 squared, squared. Okay, let's go simplify where we can. So we have f double prime of x here. Negative, don't forget that negative out there. When I was doing the notes here, it kind of got me. Now notice here, I'm actually seeing an x squared minus 4 and x squared minus 4, and kind of this whole multiplication, and then down here. So I'm going to pull that out first. So I'm going to pull out an x squared minus 4. And again, how do I do this? That minus sign I like to put with right next to the division symbol. Put a bracket, Okay, and here I kind of simplified what we have left over. So if I pulled out that x squared, or minus 4, we have 1 left over here, and this one gets kind of canceled out. So I don't have to worry about that, so I don't get confused. Multiply 4x to the third times x squared, that's a 4x to the 5th power, got that? 4x to the third times a minus 4, minus 16x to the third power, minus 24x times x squared is a minus 24x to the third power. Negative 24x times a negative 4 is a positive 96x. Then multiply this all out. Well, 2 times 2x, let's combine these two here, and we have a 4x right there. Okay, so multiply that, 4x times an x to the 4th power here. 4x times x to the 4th power is we have a minus here, 4x to the 5th power. And then negative 4x, right, because we're minusing, negative 4x times a negative 12x squared is a positive 48x to the 3rd power. Bracket complete. Oof. Over the denominator, x squared minus 4, and raise a double exponent, multiply 4. 2 times 2 is 4. Now, we at least can cancel this one thing out, makes it a little easier. X squared minus 4, and make this just to the 3rd power. Okay, we're running out of room, so I'll do it up here. Send it. F double prime of x here. All right, F double prime of x. Well, we combine our like terms. Now notice here, we have 4x to the 5th cancels and a minus 4x to the 5th cancels. That's nice. Now we have to add x to the 3rd power. We have an, don't forget the negative out here. We have negative 16x to the 3rd minus 24x to the 3rd plus 48x to the 3rd is an 8x to the 3rd. Then we got all those. I'm going to make little marks to make sure I got everything like this. Got it? And then 96x is left over. Okay, 96x, got that as well. All right, everything in the numerator is covered. We just have our denominator, which is that x squared minus 4 to the 3rd power. And this came out pretty, well, easy, right? Or simplified. We got some more work to do, and hopefully I don't run out of room here. I might have to like come back around. We'll see. All right. So the things to worry about here for our inflection point. So I'm gonna look at my numerator and we'll look at my denominator here and see where. Oh shoot! I can simplify this one more time. F double prime of x. I got ahead of myself. Let's pull out an 8x in the numerator. It's a little easier. Minus. We have an 8x here, and I have an x squared plus 12 left in the numerator. Denominator. X squared minus 4 to the 3rd power. Let's follow my notes here, Sean. All right. So now let's go set the numerator. There's values where we get equal to 0. All right, we set the numerator equal to 0, find some points of inflection, and same with the denominator here, looking at it. So we know the numerator has 8x and then x squared plus 12. So if I set 8x equal to 0, x equals 0, that's an easy one right there. X squared plus 12 equal to 0. Okay, subtract 12 to both sides, x squared equals a negative 12, we get square root, x equals plus or minus square root of negative 12, and we have imaginary. Nope, can't do that. Alright, so we're not going to be dealing with that one, don't worry about that. Now the denominator equal to 0, okay, we have an x squared minus 4 all to the 3rd power, equal to 0. Solving for that, third root both sides, doesn't matter to 0. X squared minus 4 equals 0, x squared equals 4, and x equals, we square root both sides, plus or minus 2. Okay, so we got a lot going on here. We're going to fit this in. I think I can probably fit it in over here. I still have my information written. So I'm going to put all of our values in our little table here. I guess, well, yeah, I'll fit it over here. So we have a little table. Like so. We have values at negative 2, 0, and a positive 2 here. Okay? And we're going to plug in values, okay, that are less than negative 2, between negative 2 and 0, 0 and 2, and greater than 2. And these are these values right here. So I can circle here to help you out there. Okay? Alright, so I picked values into my second derivative. Let's mark that right here so you know where that is. Alright, so I picked a value, f prime, I'll put it down here actually, f double prime of a, what did I pick, negative 3? Yeah, negative 3. And that equaled a 4.032. I just care that it's positive and we're concave up there. I found a value between -2 and 0, which was -1. So f double prime of -1 is equal to a -3.852. It's negative, that's all I care about, concave down. Between 0 and 2, I found f double prime of +1, and that came out to be 3.852, all right, and that is positive, so we're concave up here. And at 2, or greater than 2, I picked 3, so I said f double prime of 3, and that is a -4.032. That's a negative value, we're concave down here. All right, so now here's actually the tricky point, the tricky part here, okay? Let me find where my notes are here. There we go, all right. So we're discontinuous at -2 and 2. That's we have asymptotes. And so those values aren't actually our inflection points, even though we change concavity. It's not an inflection point. The only inflection point we have, is right there at 0, we change concavity. At x equals 0, right here. Okay? Either -2 and +2, we change concavity. It's not an inflection point because there's asymptotes there. We're discontinuous there, so we can't have a point of inflection there. We're concave up on our interval from -∞ to -2, and from 0 to 2. We're concave down from -2 to 0, right? -2 to 0, and from 2 to +∞. All right. So again, our final answer here is we're discontinuous at x equals -2 and +2. Our inflection point is only at x equals 0. We're concave up from -∞ to -2 and 0 to 2, and concave down from -2 to 0 and 2 to +∞. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you, for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.